Hey everyone, welcome back to the lab. In this video, we're going to be diving into more F# HTML rendering benchmarks, this time focused on the Giraffe.ViewEngine library. So recently I've been experimenting with server-side HTML rendering with F#. In the process, I've tried a few different paradigms to try and find one with a good balance between DevX and performance. First one is HTML templating with Scriban, which you can check out this guide and these benchmarks for more about that. And then the other one is raw string HTML templates or rendering, just using verbatim strings and string interpolation. You can read more about how I'm thinking about doing that here, and then other benchmarks here, which show that raw string is beating out Scriban by quite a bit. Now the problem is that both of these approaches have their own drawbacks. So Scriban templates, they tend to lose build time type safety as we cross the boundary between raw string templating and type safe data population. So templates work is you've got mostly HTML and then you've got some sort of like templating language in here, and then usually at runtime what you're doing is you're going to be taking your types and connecting it with the template, which means that you probably are only going to find these issues at runtime. So as soon as you try to fill in that template with the actual data. And so we kind of miss out on all the benefits of the F# type system here, because we're now moving things to runtime, which is like, kind of lose out on the static typing. So that's the problem with Scriban templates. So that's why, I initially moved over to raw string templates because it's a lot faster, and because it's just, built-in string interpolation, you actually get all the power of the type system because you're not doing this like runtime checks. It's literally just, oh, the variable goes in here and can it be turned into a string? But they also have drawbacks, which is that the raw string templates are hard to compose in line because F# doesn't allow for nested verbatim strings. And so the verbatim strings are like those triple quotes that allow you to basically have a bunch of new lines and stuff, which is really great for building HTML because, F# compiler doesn't know what HTML is, so you kind of need to build it in a string format so that it can kind of use it later. But one of the good things about these, templating engines is it's going to allow you to basically build like for each blocks or if blocks inside of the HTML. And so you could do like for each, list item, we're going to create an li or something, which works with templates. But if you try to do this in F# with just the interpolated strings they have now, you actually can't nest verbatim strings. And so the only way to go about this is to have your block here and then build this kind of HTML above it and then use that later on. But the problem is this kind of breaks the principle of locality because this is more composable, this is more functional, but it's harder to see what this actual markup looks like in its end state, which ultimately makes this kind of HTML model that we're building a lot harder to work. But there are solutions. So to solve for these, the F# community often reaches for HTML DSLs, which is a domain-specific language, like Giraffe.ViewEngine, which allows you to build HTML pages directly in F# through function compositions, read without raw strings, and thus solves for both type safety and inline composition concerns. But they're also notorious for being hard to read and maintain due to their abstraction from the underlying representation, HTML. And you've probably seen this kind of thing in a lot of different languages where you're not actually building up the HTML, but a lot of people don't like them because it's just another layer of like translation you have to think about, which often is just more complexity than it's worth. So in this post, we're going to explore one of these concerns, whether the Giraffe.ViewEngine DSL exhibits performance issues rendering large HTML pages. So the main question we're trying to solve is, how does HTML rendering with the Giraffe.ViewEngine DSL compare with the raw string and Scriban? Okay, and here's the summary. The Giraffe.ViewEngine is astonishingly fast, outperforming both raw string and Scriban templates in every scenario benchmark. For smaller pages of about 10 to 100 items, Giraffe.ViewEngine renders about 1.5 times faster. And for large pages in the 500 plus items range, it renders 2 to 3 times faster. My hypothesis for Giraffe.ViewEngine's standout performance is its use of F# native data structures like lists to build up markup efficiently, and its clever use of string builder pools to convert that structure into a string, minimizing expensive string operations. String operations are always super expensive in basically every language, and so especially when we're building up HTML in a string representation, usually this is going to be the bottleneck and kind of be the difference between these performance results. So here's a list of the summaries for each number of items. So at 10 items, Giraffe is finishing quite fast, and 17 nanoseconds, which is 1.4x faster than the last. And then we can see at 100, it's 1.6x, 1.6x, 4.3, 2.8, 3.2, 2.7, and 2.8. With really the standout here being able to render a list of 5,000 items, which is like a super large list. You would probably never return a page this large. Even like a JSON, data API return of 5,000 seems like ridiculously large. But this thing is able to do it in about 7.4 milliseconds, which is incredibly fast for something like that. So that's the summary. If all you wanted was the summary, you can stop watching the video now. And the rest of this post, we're basically going to go into more details about these benchmarks so you can can kind of understand where these numbers are coming from. Okay, so the first thing is the benchmark setup. And basically what we're doing here is we are building a table, and then we are seeing how long it takes to render different amounts of elements in this table. And so what I would call this is basically a long and shallow page. You could imagine just like a list of blog posts or a list of, I mean, here it's like a table, so like Excel rows or something. It's just a dumb list, but there's no complexity here. We're not like dynamically generating new components and shoving those in. All we're doing is just rendering a very long list. So really what we're checking here is like the render speed for large elements. So this benchmark's workload is to build an HTML table containing in GUIDs, which are randomized strings, and render it as an HTML string. This largely benchmarks a paradigm's ability to render long, shallowly nested pages. We are comparing 4 paradigms for HTML building. The first is the raw parser, which are Scriban templates, where the template is parsed every time and rendered over the input data. For most templating languages, you have to parse the template so it's in a model that whatever the library is understands, and then once that thing is parsed, you can actually connect it with the data, and then that's how it's going to be able to put those together and render something that's actually usable. The cache parser is basically the same as the raw parser, but we're just caching the template that we parsed. So Scriban templates where the template has been pre-parsed and saved, so we only have to render the input data every time. And this is a good way to just kind of understand what's the overhead of doing that parsing from template into whatever the intermediate model is every time. The next one is the raw string, which is a paradigm where we build up the HTML manually using raw string concatenation. This is what I was talking about earlier with the verbatim strings, just using normal interpolation here. And then if you're doing like a list of things, we'll just concatenate them at the end so that hopefully we're only doing these kind of like string adds once. And then finally, we end with Giraffe.ViewEngine, which is the new one that we're testing here, which is using the DSL to build up a representation in memory, then rendering that to an HTML string using Giraffe built-in. All these results were created by utilizing the benchmark.net library for running and tallying results on a replit-free instance. And the link to this replit will be available below if you want to play around with that. So we're not going to be going into detail about how all of these different things works because I have plenty of other guides and deep dives into those. So if you are looking into Scriban templates, you can check out this post here, which will be linked below. And then if you want to learn more about building HTML with raw strings, you can check out this one, which is also linked below. And I don't have one for Giraffe.ViewEngine yet, but I'll probably be making one soon. But if you're interested in how this looks, you can also just come over here and look at the benchmark code section, which has all the source code to kind of give an idea of how we're building this. Okay, next let's dive into the detailed results. So in this section, I'll be sharing raw benchmark outputs for posterity and later reference. So I'll probably just go over these pretty fast. So at 10 items, Giraffe.View finishes in about 17 nanoseconds, which is 1.4x faster than the next runner-up, which of course is raw string. And then we see cache parser and raw string at about 1/10 of a millisecond over here. And here's the benchmark.net output. Next, at 100 items, Giraffe.View is finishing in 1/10 of a millisecond, which again we'll see is 1.6x faster than the runner-up, which is raw string here. And then we see that raw parser and cache parser coming in at about 1/2 a millisecond. Okay, next at 200 items, Giraffe.View is in 0.2 milliseconds, which is about 1.6x faster than its runner-up. Again, raw string here at 3 milliseconds, and then both cache parser and raw parser, the Scriban templates, are coming in about 1 millisecond. Now at 500 items, Giraffe.View is coming in about 1/2 a millisecond, which is still really, really fast for this much, and 4.3 times faster than the next runner-up, which is raw string. And we can see that raw string actually got quite a bit slower here at about 2.1 milliseconds, and then Scriban is at 2.7 and 2.8. Now, at this point, I was kind of confused by the results. So Giraffe.View's results were so much faster that I assumed I was building its HTML pages wrong. I debugged and compared the outputs, and they seem to be outputting the same thing as the other paradigm, so I think it really is just that much faster. Like, this was a very surprising result for me, and I thought that surely I was just doing something wrong, but I double-checked this multiple times by just outputting the raw HTML and making sure it's like the same thing for each of these, and it really just seems to be the exact same, and this is just quite a lot faster at doing this rendering. Here's the benchmark outputs, and now for 800 items, Giraffe.View finishes in 1.1 milliseconds, which is 2.x faster than the next runner-up, which is raw string. And you can really see that Scriban is kind of slowing down here, and we'll see in a minute that it's actually reaching its limits. But here it's finishing in the 8 milliseconds, which is still fast, but just compared to raw string at 3 milliseconds and Giraffe.View at just 1, is quite a lot slower. And then finally we reach 1,000 items where Scriban does hit its reflection limits, which we talked about previously, so you can just look at the other benchmarks if you want to learn more about that. And Giraffe.View comes in at about 1.4 milliseconds, and raw string at 4.4. So both of these are very fast, but Giraffe.View is just like so much faster at about 3.2x. And so in my previous previous benchmarks, I actually stopped around 1,000 items because at that point it was really only the raw string that was completing. But both of these are doing fast enough that I decided to just like keep going and see kind of if we could get them to like an unreasonably slow state. And so here we are keeping going. So at 2,000 items, Giraffe View is still rendering in just under 2.7 milliseconds, and then raw string at 7.4. So Giraffe View is still about 2.7x faster, and infinitely faster than Scriban, which couldn't handle this much out of the box. And then finally up to 5,000 items, we see that Giraffe View comes up a bit to 7.4 milliseconds, and then raw string comparatively is at 20.5 milliseconds. So Giraffe View is about 2.8x faster. So this is where Giraffe View really starts to astonish. At 5,000 items in less than 10 milliseconds, we're actually seeing render times fast enough that you could reasonably do this in production. I'm not saying you necessarily should, but it definitely seems you reasonably could. Yeah, 5,000 items is like kind of a ridiculous amount of items to put on any page, like not even for just performance reasons, but just like user experience reasons. Like, why would you do that? You're probably not going to look at all 5,000 items. But at 7.4 milliseconds, like this is still so fast that you could actually consider starting to do this. Obviously, this is a simple page only doing strings. So if you're actually building a real page, this would probably be quite a lot slower because you're adding more complexity, but it just kind of goes to show you that other ways of rendering stuff kind of can change what's possible here. Okay, so that's all the detailed results I had. The benchmark code is available here. So here's the replit if you want to check it out. This is exactly what I ran to get these results. So you can just fork it and take a look, run it, whatever you want to do. And I've also copied and pasted it here for posterity, kind of the state of the code when I took these benchmarks. So you can check that out. I'm not going to go into too much detail here because I've done this in the previous benchmarks. So if you want, a walkthrough of what these are, just check out those. The only thing I'll show you is the Giraffe View because it's a little bit different. So you can see here that, we're building HTML strings. The way that Giraffe View looks a little bit different is we're building these little they're basically function composition. These are just little functions that internally knows that this represents a body tag, and it'll have children in here, and then it might have some attributes. And this is how it's kind of avoiding that string interpolation or concatenation overhead as you're building up your dynamic things, where we can't get that with a lot of the other string approaches. So that's what it looks like. Can learn more at the GitHub. It's really good. And we'll kind of wrap this one up. So I've been pleasantly surprised by Giraffe.ViewEngine with respect to both its DevX and performance. Often there's a trade-off between these two, but here Giraffe seems to win out in both. At least, a lot of people don't love the HTML DSLs, but the DevX wins at being able to kind of do these F# logics in the template, I think is really important for kind of building these UIs and making sure that it's building the markup as you expect. And I think this has a pretty good balance between the type safety of it and still being able to do it in place to get that kind of locality benefit. So to be fair, I'm still a little hesitant to go with the DSL because it's not easily portable. But I've come around a bit after using it for some experiments and think the short-term ones are likely worth any portability issues later on. So for instance, like with the, raw string concatenation, it's basically just the HTML. So you could just copy it over and just replace, where the variables are with whatever the new language is. Same with these kind of string templates, because you can just take it out and then just replace kind of whatever the conditionals are with the new language. But when we're going to a DSL like Giraffe, we're actually just writing F# code. And so you can't just like copy and paste that because you have to do the translation between whatever that is into the XML markup of HTML. But given the ones, with the composition capabilities, which allow for better locality of all of this logic, and how much more performant it seems to be, I think, doing this is probably worth it because you can probably stick with it for quite some time before you need to, move off of this to something else. Now, if you like this post, you might also like building a simple F# web API with Giraffe to get started with Giraffe. To learn more about how I'm thinking about building server-side rendering, especially with the raw string HTML approach, you can check out Build a Simple Markdown blog with F# and Giraffe. And then if you just like benchmarks, you can check out F# versus TypeScript performance, sorting 1 million elements. That's it for this video. Thanks for watching, and I'll see you in the next.